Hello and welcome to another Solana tutorial. This is gonna be a bonus video. We're gonna talk about Anchor CPIs again, but in more detail and in combination with PDAs and actually signing, because that is something we have not done in the main tutorial. So bonus video it is. Yeah, I should have kept a bit more focus on that instead of doing the errors. But yeah, well, that's what we did. And now we have a bonus video. I could make the other one longer, but then I think it's good to one more time reiterate why we actually use CPIs. Because what we discussed last time, yes, we just call another program. So far, so good. But then really the main use case of CPIs is actually that we can sign as a program. So our program can be the authority for something. And then by using signer seeds, we can sign for a given address that is a PDA. And that's ultimately why CPIs are so powerful. And so we also want to have a deeper look into CPIs with signer seeds in Anchor. Welcome to this video. Yeah. Okay. So remember last time how we did this CPI? This CPI, I just like to have my hands a lot. And no, I'm not too big. There's nothing down here that is interesting. Let me wave my hands around. And then the same thing with the Solana style, but we will ignore that for now. Let's just do 2 GMs. For now, we can call this GM program. Anybody can call this instruction, right? Because all you need is this program that's not even used. So we built both of the programs, we deployed them, and now run the test passes. And if we were to check that out, then we would see 2 GMs. Perfect, because we can just call it like that. Now, what if in here, in our accounts, I would require an additional signer? Because this thing will do the checks for this account to be a signer. Then I need to also here in the CPI provide this. And actually I could get rid of the GM program because I wasn't really using it. So let's get rid of this thing here. And then instead of this GM program here, we now need to provide the signer. The signer could now either be a user wallet or a PDA. And since we want to sign with seeds, it's gonna be a PDA. So let's also put that account here into my GM accounts, my PDA. Should I do something that you shouldn't do and be a really bad example again? I'm gonna use an unchecked account. But only because I really know what I'm doing, of course. See, this account doesn't even exist. We won't make that account exist. We won't put any data there. We won't even put lamparts there for the account to be in memory of the validators. We literally just use this such that we can sign as our program. We do, however, check for certain seeds. So we do check the address. I don't know, just signer or just authority. Why not? It's just my authority. There's one authority for the program. So that's the only seed and the bump I want you to calculate. And I don't init that account because I don't need any data on it. I literally just want the address to be checked to be this specific address. That is the PDA with that seed and the canonical bump, as we have learned, 2 lessons ago in the Anchor PDA video. And then I can use this PDA to sign when doing a CPI. Actually, first, before we do that, let's check what would happen if I were to just give any account info here. And now it tells me PDA is unsafe. Add a check. Okay. So as I mentioned, don't do this at home unless you really know what you're doing. This account is never written to or read from because it doesn't even exist. It's just used for signing. Okay, that's enough documentation for you. Now let's check if we were to just give the GM program here as the signer. Then it will probably complain, oh, this is not actually a signer, test failed. So transaction simulation failed, cross-program invocation with an unauthorized signer or writable account. And then we probably get more detail. I would expect the signer privilege escalated somewhere. No, don't see that. Okay, fine. But anyway, it tells us, well, something is wrong with that account. It's not actually signing. So you're saying we should take the GM program here as this signer, but then here we check that this is actually a signer. So that's why the GM program will be like, no, this is not how this works. It needs to be a signer. And that's why this fails. Now, the GM program obviously cannot be a signer, but we put in this PDA here now, and this guy will be able to sign. So how do we do this? Well, first of all, we change this to the PDA. Oh, by the way, even if we put the PDA here, it's still not signing. So even if I run it now, it will still tell me, well, this is not a signer. Cross-program invocation failed with unauthorized signer or writable account. But in this case, it's unauthorized signer. So how do we authorize this? Well, by adding a signature for the PDA. And how do we do this? By not making a new CPI context, but a new with signer. And then we can add the seeds as the third argument, which will be exactly the same as below. So we have to write, what did I say? Authority and the bump. How did that work? Context, bumps. Yeah, I don't remember. Context, bumps, get, and my account was the PDA. So for the PDA, please get me the bump, raise the error if there is one. So if you don't find the PDA account, but you should find it. And then add that bump to the list of seeds here. I still have a brackets problem, I think. Yeah, okay, I see. You need to be another slice. Okay, and now? See, and this is the point why I'm doing this video, because I want to learn what all of this means. And okay, now I get it. Now I get it that I'm too big, so I'm gonna get smaller. What is this error? Temporary value dropped while borrowed. Now I don't fully get why that is the case. If I put the CPI context down here directly, then it won't complain about this. It's just that I create this CPI context and let it live longer, that is a problem. If I do it down here directly, then I don't get this problem. So let's start with this. And look at that. All of a sudden, the PDA is a signer and I get back a signature and 2 GMs were printed because the CPI worked, because I provided a valid signer. Now this could also be any signer. It could also be a wallet signer. In our case, we signed with the program though. We signed with signer seeds. And that's basically where I wanted to go, right? I could stop here and be like, okay, we did it with signing. Okay, I mean, not that much new stuff that we learned here, right? Like we just practiced it one more. By the way, same with if we were to do it here, then we would just do invoke signed and then here add the signer seeds in the same format like this. And then that would also work with a Solana program style CPI. But this is not why we're here. If I now move this CPI context out and just provide the CPI context like this, then it complains here that a temporary value is dropped while borrowed. So we borrowed this temporary value and then it's being dropped, so it doesn't exist anymore when it's used here. So the way we get around this is we also save ourselves the seeds and then just put the seeds there. And now it's probably going to complain here, yes, because it expects the same length for this slice as it does for this, and that's 9 characters, and then it expects 9 but just gets 1 byte from the PDA from the bump. So the easiest way to fix this, and yes, you also just gotta learn this once. In the beginning this confused me a lot, and now I'm just like, well, I just defined a type of view that you are a slice of U8s, and bam, all of a sudden it doesn't complain anymore. Easy, right? If you know what you're doing. So with that compiling again, let's try it one more time. I'm also going to add a message so that we can be sure that we're actually using the newest version. And drum roll. Also passing. Okay. And even this gives me the 2 GMs and the CPI is successful. So we did use this version. Cool. So that should actually work. It's not that difficult. So I didn't learn anything unexpected here, but I was hoping that I would, because, And we're going to leave this example now and go to a more complex one, the one where I'm trying to send cNFTs out of a PDA account. Here, I'm essentially doing the same thing, except I'm calling MPL bubblegum, the transfer, with this context and this data. And the context contains all of these accounts plus the remaining accounts, because last time we found out how to add the remaining accounts. Then it also contains the signatures. So I add with signer. The seeds, I could also just write new with seeds and then put them in there. It's same. And in my attempt to make it work, I even tried to set vault is signer to true in this account info, such that the leaf owner is definitely a signer. But then when I try this, let's say I want to get this asset out of the tree. So I call the withdraw cNFT with my proof in the remaining accounts. If I run this, first it should print me the asset that it gets from the read API. That's the asset on the read API. We see that the owner is the 2G and that is my PDA. But then I get the anchor error, leaf authority must sign, which is a 6K25 error. So it is a custom error of the program. So it's an MPL bubblegum error. And the message is this transaction must be signed by either the leaf owner or leaf delegate. And we can even check in the code. There, that's the error. And it is used here. There in the transfer instruction. There is a require, and we learned in the last video what that does. It assures that this is the case, otherwise it returns this error. So the owner or the delegate must be a signer. So owner.signer must be true or delegate.signer must be true. And in my opinion, owner.signer is true in my case, because the owner is the leaf owner to account info. And here the owner, that's my vault. And for my vault, I set the is signer to true. Then I provide the seeds such that it can actually sign for that. But somehow it just doesn't do that. Somehow, even though I provide the seeds, it doesn't add the signature. Or the other program just doesn't see it. I don't know what I'm doing wrong here. I still don't manage to get this thing to run. I managed to call it, but then it fails because it doesn't have the right signer. And I don't get why. Because the seeds should be correct. It's cNFT vault, and the bump for leaf owner, and the bump for leaf owner. That should be my seeds. And I sign with them. And I even printed is signer. And in the simulation, we can see it is true. It is set to true. I don't get why this is not working. And this is the part of the video where I'm now also just lost and have no idea what I'm doing. Because in my opinion, that should just work. And I know that it does work because I did it with a regular CPI by using the system program invoke. So by adding those seeds, it was able to sign for that account. And the account I created with the account meta, leaf owner, read only, and signer true. So that's how I did it. Maybe I also gotta do it somehow like this. Maybe I just set it in the account info and not in the account meta. Hold on. But here I just give it the account info, because the transfer just wants the account infos. It doesn't want the account metas. But then it also does two account metas on those actually. I think it's just not setting the signer flag correctly. You know what else I found? The two account metas has a is signer field, an optional one. And this is signer field is used to override for the signer meta field. This covers the edge case when a PDA needs to relay a transaction from a client to another program, but sign the transaction before the relay. And that's exactly what we're trying to do. We are trying to sign for this PDA. So wherever this is called, the two account metas, it's not using the is signer, I think. Transaction must be signed by either leaf owner or leaf delegate. I don't get it. Okay, but let's go back to our example. Because let's say I were to provide the wrong seeds. What would that mean? What would the error message look like? Would it just also fail at the other program and say this is not a signer? Or will it already tell me it didn't find an address for those seeds? Because doing things like that will help me debug. If I know what error comes when, then I can make better decisions of what is actually going wrong. So the error here will be just the simulation failed because cross-program invocation with unauthorized signer. So it doesn't give me any indication that the seeds I provided here were not used in any of the accounts. So that's the same as if I would just not provide the seeds. But that's annoying because I would really like to have a different kind of error. If I do the same thing as here though, and be like, is this account's signer a signer? What would I expect? I kind of would expect it to say yes. Even though here it is not a signer yet, that's just a PDA, but here it should know to make this one a signer, right? Or maybe that's just a wrong assumption that I have. See, it doesn't give me the full output, that's annoying. Give me full output, sir. Do I get a stack trace now? There, at least now I get the full output. That's what I want. False. So it's not a signer. It's not even making that a signer. And then it fails because cross-program invocation, there, signer privilege escalated for this account. That's what I was looking for. Okay, that seems to be the PDA. Okay, how can I force this one to be a signer? Well, I could give it the correct seeds for the first thing. Wait, if I give it the correct seeds, then it will just make it a signer, right? So if I give it the correct seeds, then is signer will be true because it just matches the address that it gets from deriving with those seeds again and set that address to is signer true. That's how this works. And then it should go through again, which it does. And then we can look at this where it should say, but interestingly, it still says is signer false. So it doesn't care about that one. It doesn't give a shit about whether or not I set this signer to true or false. Even with those seeds here, the signer is false and it doesn't really care about it. It's still a signer in the other program then. And I make it a signer just by providing the right seeds, right? There's nothing else that I need to do. This context has no way of knowing that this is supposed to be a signer, or does it? Or does it know that because I specified it here as a signer? Let's do another experiment. What if this, my favorite, would be an unchecked account? Then the GM program doesn't check for signer anymore. This is safe. Trust me, I'm a dev. Signer signed from my context accounts is signer. We're gonna get to the bottom of this eventually. So does it say signer signed or does it not say? Deployment success. And signer signed is false. So it doesn't automatically make it a signer just because I provide the right seeds. Okay, now we have the same problem as on the other side. How, if this anchor program does not require it to be a signer, how can I still sign for it? I mean, I am providing the accounts here. I know how I could do it by using a normal system program invoke, using the PDA here, creating myself a new account meta and putting this to true. This should actually set me the signer to true. And then also in the other program have it be a signer, but that's the non-anchor way. Sorry, I of course need to do invoke signed and add the seeds. My bad, I missed this. And test does not go through. Error processing instruction. An account required by the instruction is missing. Oh, my bad. Of course, need to also provide the right PDA here. One more time. So frustrating how long this takes, even on local validator. Just because my machine is so slow. Because I'm recording as well. Okay, but now. Ding-a-ding-a-ding-a-ding. Bam! There we go. Confirm on local this one. Oh, I just can't type. Because R and F are so close together, my fingers always get that effed up. See, but here it sets it to true. How can I make my anchor CPI do that too? So that's essentially what I want. How do I do that? here with the CPI context. If I figure that out, then we really learned something today. A very niche thing, but yeah. I want to essentially force you to set that one to true, to expect the signature for it, to force the signature onto it. Force the goddamn signature onto it. Can I just replace the accounts manually with something else? Or do you really expect some GM Anchor CPI accounts here? Yeah, trust me, I'm a dev. Maybe let's cheat a little. Yeah, you just don't want me to fuck around with that, I understand, but then give me a way to properly set it as a signer, damn it! The task is so simple. Make this a signer, and yet it's so difficult. That's a disadvantage of Anchor over native Rust, where you can just set true. Easy. So there we go. That's the disadvantage of abstraction. It abstracts away the very easy stuff that you always do the same. But as soon as you want something very specific, different now, then it suddenly doesn't work. Or it gets super complicated to find a workaround or whatever. Set the signer to true. Does that change anything? I'll do half an hour more, and if I didn't manage by then I'm gonna give up again, because it is not that easy. It is not trivial, at least. I want to make it work though, because otherwise the whole point of this video is like, boring, I couldn't make it work. See, now my ego is like, we can't publish that video if we don't fix it, so you better fix it. Ooh, we could go with our default strategy and ask on Twitter. First look at that. So the signer is false, even though here I set it to true. So that's also pointless, you know? I mean, we've also seen it in the other program, but even if I set my signer to true, it still doesn't make it a signer, even if I provide the goddamn seeds for them. Okay, I'll ask Twitter. Tweet them all. This is amazing. The man himself, Matt Amani, is replying to my tweets and helping me out. See, it's just a community thing, right? Like, he takes his time to help me figure this stuff out. He's also like, yeah, you just need to mark the thing as a signer. And I'm like, yeah, but what if it's not? What if I want to force it? Any solution for that, Mr. Amani, sir? Manually invoke it. So, according to the man himself, I need to manually invoke it. So Anchor intentionally makes this an anti-pattern. I strongly encourage single-purpose instructions. Optional signers and optional things in general lead to bugs and vulnerabilities. By manually invoke, I mean the underlying invoke signed API. Okay, so that is also a possible end for this video. And let me get bigger for this. Because essentially the guy who built Anchor himself telling me it's not possible. And if he says it's not possible, then it is not possible. Thus, we can stop searching for the answer, because there is no answer. Neither this nor this will work, ever. They explicitly made it an anti-pattern to have an optional signer. For it to be a signer, I would need to specify it as a signer here. But I can't make this unchecked account a signer unless, of course, I do it manually with invoke. But that's not the Anchor way. Anchor tries to avoid it, which makes sense, because for most people, you really don't want to use unchecked accounts, and you also really don't want to make an account as a signer that is not supposed to be a signer. So who's to blame here? Well, maybe the guys who developed NPM Bubblegum? Bad Metaplex, bad Metaplex. Design your Anchor programs better so that I can call them with a CPI context, the Anchor style. So what they would need to do here for this transfer, they would need to do two instructions. One is the transfer with the owner being the authority, and then have the owner be an actual signer. So you could do transfer, and another one, transfer delegate, where you have the same accounts essentially, but the delegate is a signer. Because in this case, both of them are just unchecked accounts, and I can't make them signers. So that's on MPL, not on me. Which also means that my reference implementation with this manual way of building the CPI is the only way to do it. So I can't do a pull request as I promised in the last video. And that's okay. just now we know it. And I can say, well, it is like that. And I have to do it that complicatedly because MPL. Not to blame anyone or point fingers, but just saying it's not my issue here. Because I spent my hours trying to fix this stuff, but it's not fixable. If you believe that guy, which I do. Yeah. Handshake. But this then also concludes this video. I hope that you still learned something. I certainly did. And I always like it if I learn something. This time I had to dig very deep and then take the emergency route of asking on Twitter. But that's also a valid strategy, right? If you are stuck, then you can ask for help. And that's so cool about our community, that we do help each other. I try to help you. Other people help me. That's just the circle of life. The circle of death. The circle of deaths. Yeah. I do, however, recommend first looking into it yourself and trying to learn it by yourself. I mean, I spent my 3 hours today trying to figure this out before I asked Amani, because I got stuck and I didn't see a way out. And turns out there is no way out. So, yay, I made the right decision to ask and get the confirmation, because I would not have given up. I would have just spent more and more hours on this. But yeah, there is no other way to do it. You need to do it with invoke signed. Yeah, but the basics, remember the first 10 minutes of the video? At least we also reiterated the basics. Basics with a B. So that you now totally know how Anchor CPIs work. Yeah, and I learned something. And you hopefully learned something as well. If nothing else, then that Armani is a nice guy and helps you out on Twitter. Helps me out on Twitter, in this case. Okay, good. Good enough for a bonus video. I will see you in the next one. Till then, bye-bye. You can also check out the first video in this series where we talk about Anchor CPIs in general, and also something that YouTube recommends to you. And like and subscribe and all the good stuff. And I will see you around. Helping you, helping me.